Hello everyone. In this video I will explain to you the exam question which we have on the tutorial 3 sheet. So we have the following situation. We have p random variables x1, x2 until xp which make our original data set. And we assume here that we have identical random variables, so every xi has mean 0, variance sigma squared. Then we determine the z1 as a linear combination of the xi's, where the weights are determined by the vector alpha I, which we derived during the lectures. It's the first principal component, which means it's an eigenvector of your variance-covariance matrix. So this here holds. And what we have to prove is that the correlation between z1, my first new variable, with this correlation with z1 and xj, my original random variable, that this correlation can be expressed using this formula. Alright, so what we will do. We start with the definition. So the covariance between z1 and xj, I can write by plugging in here the expression for z1. We can then use that the covariance of the sum I can write as a sum of covariances. And then I can also take out the alpha 1i and use that these covariance xi, xj I can write as sigma ij. So this sigma ij is exactly the covariance between xi and xj. Alright. We can use the fact that a covariance matrix is symmetric, so then this expression I can also write as alpha 1i times sigma ji. Alright, that's step 1. We also know that the alpha 1 satisfies the following equation: the variance-covariance matrix of your xi's multiplied with alpha 1 is equal to lambda 1 alpha 1. If we write this down in full, we get the following. Alright, so this is the expression that you find. And then we see that this expression here actually means that we multiply this row of sigma with the alpha 1 vector. And that should be equal to this value. So I can add here the equality that this is equal to lambda 1 alpha 1, not p, alpha 1 j. Alright. So then we calculate the correlation. So the correlation between z1 and xj is equal to the covariance divided by the standard deviation. So it's the covariance which we just determined, z1 xj, divided by the standard deviation of z1 and the standard deviation of xj. The variance of xj is sigma squared, so the square root is sigma. The variance of z1 is equal to lambda 1, so I get here the square root of lambda 1. So this becomes lambda 1 alpha 1 j divided by square root lambda 1 sigma. So then we can simplify this and we get the formula square root lambda 1 alpha 1 j divided by sigma, which proves our results.